All right. Uh, Again, if you haven't checked in to on campus, please do that. A couple of people still haven't. Um, Second, what we're gonna do today. Today revolves around putting everything you see on your screen together, which seems really overwhelming at first. Okay, well, we're gonna kind of take it step by step, um, and give you kind of like a process in order to do all this stuff. All right. So I want to review this. So what's on your screen? Then I want to go over questions over R7 and R8, which it seems like pretty much everyone is asking the same type of question. So hopefully we can get through that decently quickly, and then we'll go over kind of how to put this stuff all together. All right. So on your screen right now, this is literally everything we've gone over so far this chapter. All right. And while this may seem kind of boring, and I don't know, like not real life ish, this is really how you find distances in a lot of different things. All right. So it may not seem like it, but we're actually finding angles of elevation and distances. All right. Which this, right now, I'm thinking that this will actually culminate in a project that we'll do. All right. Uh, but for now, we need to focus on how to actually use this stuff. So far, we've gone over labeling sides of a triangle given some reference angle. All right, and I think someone asked this in on campus. How do we know which side is opposite an angle? Well, that's where this kind of image comes in. Um, it's drawing lines from angles, and that's how we get it. All right, so from your angle, the angle that's given, if you draw a line to the opposite side of the triangle, like the other side of the triangle in red, that gives you your opposite side. All right, if you draw a line to the other side of the triangle from the right angle in white, that gives you the hypotenuse. Okay, and then the side left over, that's the adjacent side, because that is the side attached to the angle that is not the hypotenuse. All right, so that is like super important, and that's why I've kind of gone over that several different times. All right, so if you need that image up in front of you, use it. The quicker you get that, the better, because that does stuff using this will show up on the ACT, and it's helpful to have and know right off the top of your head. Okay, after that, and actually before we get to SOHCAHTOA, we went over the Pythagorean theorem last chapter actually as kind of a lead into this chapter. That definitely needs to be known. That's super important. Again, this is kind of the basis on how you find distances. All right, and that's the adjacent side plus the opposite side equals the hypotenuse squared. All those things are squared. You guys probably know it as a squared plus b squared is equal to c squared, which is fine. But when we're talking about these right triangles, it's I'm just trying to keep terms as consistent as possible. Okay, so the more you can do that, the better. Then we talked about SOHCAHTOA. All right, and with SOHCAHTOA, especially these first three, angles have different relationships with sides. Okay, and that's all that's saying. So the sine relationship with theta is going to be equal to the ratio of opposite over hypotenuse. The cosine relationship with theta is going to be the adjacent over hypotenuse. The tangent relationship with theta, that's the opposite over the adjacent. Okay, so that's using angles and sides now. Then we went over the reciprocal functions. Okay, and the reciprocal functions are literally just the same as SOHCAHTOA. They're just flipped upside down. That's pretty much all it is. All right, and all the while we are rationalizing fractions. We're dealing with square roots, and that's kind of all built in. Okay, and then the next thing we did was use inverse trig. Okay, and so in this case, when we're using inverse trig, we're actually solving for the angle. Okay, so when we take the inverse trig function of a trig function, we're just left with our angle theta. So here I have written the inverse sine. Whoops. the inverse sine of sine just gives theta. All right, so when we're solving for an angle, we have to take the inverse sine, the inverse cosine, or the inverse tangent on both sides, and that'll give us the angle we're looking for. Okay, and we'll do an example of this here coming up in a minute. And then, kind of on your last homework, we had these values, right? Those trig values. So given certain angles, we should know sine, cosine, and tangent of 30, 60, and 45. And if you don't know it, like right this second, that's okay. But that will come in handy next year and the year after. All right. So, a couple of questions on the IXL. And a lot of these questions are the same thing. They're questions having to do with angles that aren't 30, 60, or 45. I think I have that written down right. All right. So we want to find a side given some angle and some side. All right. So the first thing we always do is label which sides are what. All right. So the first thing I usually find is the hypotenuse. So we don't have the hypotenuse. The next thing I always find is the opposite. And then the adjacent. And then we label what side we actually need. All right. So we need this QR. So we need the adjacent side given the opposite and an angle. And if you remember SOHCAHTOA, we are given the opposite and we want the adjacent. And the only trig function with both of those in it is the tangent. Okay, so we have to use the tangent of some angle is equal to the opposite over the adjacent. All right, so since we're using tangent, let's just set up our equation. Tangent of theta is equal to the opposite over adjacent. Then we can substitute in what we know. So the tangent of 36 is equal to 5 over the adjacent. All right, and there are kind of two questions that stem from this. All right, one, how do you solve for something underneath a fraction? All right, so in this case, we're solving for the denominator. And the other is what do we do with angles that aren't 30, 60, or 45? Okay, so first thing I'm going to address is how to solve for this denominator, which really we should be able to do because this is just algebra. All right, and I'm going to make some of this stuff smaller so I can actually have room to write. So the first thing I like to do is actually solve for the adjacent side before I do any trig, any plugging into a calculator or anything. All right. So I want to solve for the adjacent side. And that adjacent side is in the denominator. And in order to get anything out of a denominator, which is exactly what we need to do here, we need to multiply it on both sides in the numerator. When we do that, it cancels out on the right-hand side, and we're left with the adjacent times the tangent of 36 is equal to 5. Okay, but the adjacent side still isn't by itself. So then we just need to do a little bit more algebra, and then we'll have it by itself. Okay, so in order to get the adjacent side by itself, we have the adjacent times something. So in order to get rid of that other something, we have to divide. So if we divide both sides by tangent of 36, we end up canceling it out because on the left-hand side, again, those are common factors, so they cancel. So we're left with the adjacent is equal to 5 divided by the tangent of 36. So really what's happening, if you go back to our original, the adjacent and the tangent of 36 literally just switch places. So if you want to think of that, you can. It's a little bit of a shortcut. I prefer that you actually understand what actually happened. Um, but if you need that as just as kind of a quick way to do it, that's fine too. Okay. So I want to pause for a second. Are there any questions about that? Because that's what I saw. Some of the questions were about in on campus. How would you finish solving that? We're gonna get there in like 2 seconds. But until then, let's just. I want to make sure people understand how to get the adjacent side by itself. All right. So give me a second on your question, um, and then we'll get there. Okay. So I'll just put it this way. This algebra part is really important. Okay. So if we definitely need to know how to do this. All right, which we practice a lot with fractions right before this test. Not before this test, before the last test. Um, Dealing with these types of fractions and these type of proportions is super important. So if we need to practice that, you need to let me know. Okay. But as soon as we get here, as soon as we get to this spot where we have the adjacent by itself, and that's equal to 5 over tangent of 36, that's when we go to our calculator. And yes, your answer is a decimal. All right, so on your calculator, if you have a TI-84, you just type in 5, the division sign, and then tangent 36. Hit enter. As long as you're in degrees mode, you'll get an answer. Okay. On Desmos, which I'll use until I can figure out how to put my calculator on my screen, um, the first thing that you should do is make sure you are in degrees. So you need to go to this wrench up at the top right, go down to the very bottom of that tab that it opens, mouse over degrees, click it, and then you're in degrees mode. After that, we just need to type in exactly what we have. So 5 divided by, you can type out tangent 36, and then we get 6.8819. And I believe it will say to round to the nearest something. It says round to the nearest. I'm guessing it says round to the nearest tenth. That's cut out of the picture. Um, but if it's round to the nearest tenth, it's 6.9. Okay, so yeah, having a usually when you're dealing with degrees that aren't 30, 45, or 60 for now, um, that's you're gonna get a decimal. Okay, and that's okay. And the directions on that should kind of cue you into that because it'll say round to the nearest tenth or give an integer. Okay, so I think that answers most questions. I think in one problem we answered most questions. But I want to pause there for a second. Is anyone confused over anything that I just did? So again, some of the questions that you guys are actually having are algebra based, and some are actually like, should you get a decimal? And if again, if you're not having degrees in 30, 60, or 45, you're gonna have to use the decimal. Okay, at least for like right now. There are ways to get those in a little bit more rational, or at least some of them. But for now, you're just dealing with decimals. And again, those directions should cue you into that. Okay. All right. So now what I want to do is start to put kind of all this stuff together. All right. So I have a couple of examples that I want to do, and then I'll let you guys get to work. Um, and these are directly from the homework. All right. So in this example, we have this triangle UWV with side lengths root 15 and root 21. And what we want to do is we want to find the measure of angle V. Okay. Again, the first thing that you should probably do on this, just to be careful, and especially when you're starting all this stuff out and you're new to it, is to just label what sides you have and label what you need. Okay. So obviously we need the measure of angle V. A good thing to do is to just mark that. Okay. So I usually mark that with a little hash mark. I'll make this just a little bit bigger. Okay. And then we need to mark what sides we actually have. So remember, our hypotenuse is on the other side of the triangle than the right angle. Okay, and if we draw a line from our angle that we need, we get the opposite side. All right, so we have the opposite side and the hypotenuse, and we need that angle. So the only trig function with opposite and hypotenuse is sine, right? So we need to set up an equation. Okay, so sine of our angle theta is opposite over hypotenuse. And then we can substitute in what we know, right? So we don't know the angle V yet. We don't know our theta. So sine of angle theta is equal to root 15 divided by root 21. Are there questions about how I got there so far? All right. Then we have to solve for theta. So theta, and this is mostly algebra. We had just added another function that can do this for us. All right. So theta is not by itself right now. It has sine attached to it. It is the variable within a function. So we need to get that by itself. We need to get just theta by itself. In order to do that, we need to take the inverse sine of both sides. Because what you do to one side, you have to do to another. So what that does on the left-hand side is it just leaves us with theta, right? Those signs cancel out because sine inverse and sine undo one another. And then on the left-hand side, we still have sine inverse of root 15 divided by root 21. Okay, and because this isn't a final answer, some of you might be asking, do we need to rationalize that fraction? Because it's not a final answer, you do not, because we're going to end up having to put this in a calculator. Okay. So in order to solve this, again, if you have a TI-84 or TI-83, you would hit second and then sign and then type out that fraction. So square root of 15. And again, remember parentheses are very important. The numerator should have parentheses around it, and the denominator should have parentheses around it. So sine inverse of root 15 divided by root 21. And then when you do that, you should get 57.68 degrees. This is probably going to say to round up to the nearest tenth. So we would round it to 57.7 degrees. And that is the measure of angle V. Okay, if you're doing this on Desmos, and again on both Desmos and a calculator, we need to make sure we're in the correct mode. We need to be in degrees. Okay, so on Desmos, we would just type in exactly what we have written over here. Okay, so sine inverse, and in order to get sine inverse, go to functions, hit sine inverse, and then we just type in that equation. And we get the same thing. Again, I want to pause there. Wait, so how do we type it into calculator? So kind of the same way I typed it in Desmos. It should look exactly like that. If anything, you might want parentheses around the numerator and denominator. So it should look like that. Okay, so I'm going to pause there for a second. Are there any questions about what I did? All right, I want to do one more example of this type of problem, and then we'll move on just a little bit. So another example, again, directly from your homework. Find the measure of angle J given this triangle with sides 2.5 and 3.3. And we kind of do the same thing. So the first thing we do is we label what angle we actually need with our hash mark. Okay, and you have to do this first in order to find the opposite and adjacent sides. Okay, so if we draw a line from our angle that we need to the other side of the triangle, that gives us the opposite side. If we draw a line from our right angle to the other side of the triangle, that gives us our hypotenuse. And then the side left over, that's the adjacent. So we have the adjacent and hypotenuse, and we need angle J. So again, if we just recall SOHCAHTOA, we have adjacent and hypotenuse, so we'll be using cosine. So then we set up an equation. So cosine of our angle, we'll call it theta, is equal to the adjacent over hypotenuse. Substitute in what we know. and we solve it almost the exact same way that we just did before. So again, I'll pause there for 5 or 10 seconds. Are there any questions about what I've done so far? Okay, so now again we need to get theta by itself. So we just want theta here. We don't want cosine of theta. We just want theta. So in order to undo that cosine, we have to take the inverse cosine of both sides. And what we do to one side, we have to do to the other. The inverse cosine and the cosine, they cancel each other out. So we're just left with theta is equal to the inverse cosine of 2.5 over 3.5. And again, we can type that into our calculator or go to Desmos and do something very similar to what we just did. So when we do that, we get 44.4 degrees. And then that's our answer. So again, I'll pause there for a second. Are there any questions about anything that I've done? Okay, so I want to move on. Yeah, so you should get 40.7. I had 3.5 instead of 3.3. So your answer is right. Um, I just plugged in the sides wrong. All right. So I want to go over two different types of examples, and then you guys can get to work. Okay. So on this next set, there are kind of two different types. Okay, there's one with a 30, 45, or 60 degree angle, and then there's one with like odd angles, so like 42, 43, 32, stuff that is not 30, 45, or 60. Okay, and it just says to solve the right triangle given the figure below. All right, so we're given triangle ABC. with an angle of 30 and a side length of 5. And we want to find the length AC, AB, and the measure of angle C. So in order to do this, again, we should always just label our sides. So we're given this angle 30. So if we draw a line from this angle to the other side of the triangle, that's the opposite. If we draw a line from the other side of the triangle, or to the other side of the triangle from our right angle, that's our hypotenuse. And then the leftover side is our adjacent. And keep in mind, when you're doing this, there are different ways to solve this, right? I'll kind of do a mixture of them, okay? The first thing that I would do, to be honest, is to solve for this measure of angle C. Okay, so what we should know is that the angles within a right triangle, or any triangle for that matter, add up to 180, all right? So we know that angle A is 30. We know that angle B is 90 plus angle C, and that has to equal 180. So I could probably set that up more. I guess appealing. So 30 plus 90 plus our angle C has to equal 180. So angle C has to equal 60 degrees. Again, because the sum of the measures of any triangle have to add up to 180. So in order to find a third angle measure, you just sum all of them together, set them equal to 180, and then do a little bit of algebra. Okay, so that's the easy part. Then we can solve for AC. All right, so AC is this hypotenuse. And we are given the opposite side. All right, so we have an angle, we have our opposite side, and we have our hypotenuse. So in order to solve for the hypotenuse, we need to set up an equation. So we would use sine because we're using opposite and hypotenuse. And then I substituted in already what we actually have. Okay, then we need to solve for that. All right. Again, the first thing I would do is to just get hypotenuse by itself. So when you have something in the denominator like this, kind of just switches sides. What's on the left. All right, so the hypotenuse will equal 5 divided by sine of 30. Okay, well, I want to stop there. Are there any questions about what I've done so far? Can't you just flip them both and multiply by 5? Yes, you can. And you can do that. Again, I like to actually use algebra instead of just, like, yes, you are using algebra. Yes, you can do that. I'll just leave it at that. Okay, now we need to actually solve for hypotenuse. Okay, so the first thing we need to do is we need to replace this sine of 30, which again, because it's just 30, we have what that is equal to. And it's equal to 1/2. So hypotenuse will actually equal 5 divided by 1/2. Now, when we are dividing by a fraction, we are really multiplying by its reciprocal. So this is really 5 times the reciprocal of 1/2. So it's really 5 times 2, which is equal to 10. Questions about that? All right. So then we have one side left over, and that's AB. Now, there are two different ways you could get this. You could do what we just did, but with cosine of 30. All right, so what would end up happening is the cosine of 30 would be equal to the adjacent over 10, because we just found the hypotenuse, and then solve it that way. Or you could do the Pythagorean theorem and do 5 squared plus the adjacent squared is equal to 10 squared. Right? Opposite squared plus adjacent squared is equal to hypotenuse squared. You could do either one of those two. And it's really up to you, whatever you're more comfortable with. Okay? I will say that when you do this, which seems a little bit harder at first, it's usually going to have it in simplified form already. So you won't actually have to worry about rationalizing anything. So I'm going to do it that way, just to save a little bit of time. So if we do it that way, cosine of 30, that's equal to rad 3 over 2. And then we just need to solve for the adjacent side. And in order to do that, we multiply by 10. Which gets the adjacent side by itself. So then we have 10 rad 3 divided by 2 is equal to the adjacent. And then all we need to do is simplify the left-hand side. And we get 5 rad 3. Because 10 divided by 2, that's 5. And then the rad 3 is left over. Again, two different ways. Usually when you do it with the cosine way, it's simplified and rationalized for you already, unless you're trying to solve for a denominator. So it's kind of up to you. They both have their advantages and disadvantages. It's just what you feel more comfortable with. Okay, so that's kind of a long problem. So I'll pause for a second. Are there any questions over anything you see on your screen? Can you do it with tangent of 30 and then solve? Yeah. So you can find the adjacent side. Yeah, and again, there's a ton of different ways you can do this. So instead of using cosine of 30 is equal to adjacent over 10, you could do tangent of 30 is equal to 5 over the adjacent. Again, it gets a little bit trickier because suddenly the adjacent is in the denominator. And if you don't feel comfortable with that, then I would shy away from it. But if you do, and it's just easy for you, you could totally solve for that first. Again, a lot of different ways to solve these. And when you have all of this stuff out in front of you, you can see some patterns a little bit cleaner. All right. One more example, and it's kind of the same type, but this time we don't have a clean angle. We have 22, so we don't have 30 or 45 or 60, so we're going to be using some decimals. Okay. So this says solve the right triangle given the figure. We have an angle of 22 and a side length of 2. The first thing that I'm going to do again is to just solve for the measure of angle J, because I know that 90 plus 22 plus J is going to be equal to 180. So that's usually like the third option on your homework, but it's the easiest one to get. Then we can find JK, and actually I'll solve for IK first, just to show you a little bit different, that you can do it in different ways. So IK is this side right here, and we can label sides, I guess. So IK is the adjacent side, and we have the opposite and an angle. So we need to use tangent. We end up getting that the adjacent is 2 over the, adjacent is 2 over the tangent of 22. We can plug that into our calculator. So tan of 22 and then 2 divided by that. So we get 4.95. And to find JK, that hypotenuse, what I would do is use sine of 22. And again, you're going to get something that looks pretty similar. And then when you plug 2 over sine 22 into a calculator, you get 5.34. How do you get the answer with tangent on a calc? So we have that the adjacent is 2 divided by tan of 20. So you just do 2 division sign, hit tangent, put in 22, and hit enter. Again, it'll look pretty similar to this right-hand side. So I went over this a little bit quicker, but I do want to make sure if you have any questions, I'll answer them. So I want to pause there. Are there any questions over anything on your screen so far or anything that we've done? All right. So next, you can start on your homework. It's R9 and R10. How would we find m, the measure of an angle that has a number that are red? I'm not exactly sure what you're asking. So what I'll do is uh, I'll leave this open for a minute. If people have general questions, I'll ask them. And then in a minute or two, or in a couple minutes, I'll start a meeting on Teams. You can ask me there. That way you can show me and I can draw it out for you. Okay. So take a second. If you have any questions over anything I've done today, uh, and I can answer kind of generally on here, go ahead and ask them. Otherwise, after that, I'll start a meeting on Teams and we can go over it together. All right. So I will close this. If you have questions, I'll start a meeting on Teams and I will see you there. All right.